One of the most innovative aspects of xDesign is its design guidance functionality. This generates geometry in a model based on loading conditions. For example, this model focuses on designing a swing arm component that connects a motorcycle's frame to the axle on the rear wheel. In order to generate geometry using design guidance, you'll need to set up three key components: adding restraints, applying forces to existing geometry, and setting a build volume for the size of the generated geometry. Once these are set, you can click Generate, and xDesign does all the work generating the geometry. This is an iterative process that takes a few minutes to complete and results in truly unique geometry designed specifically for your model. In this lesson, I'll walk through the steps to create an initial swing arm design. Then I'll update the study to include the shock absorber mount and the forces applied on it. Finally, I'll take a rough block design of the swing arm and redesign it to a more optimal shape. Here I have some of the key elements of a motorcycle design. In this model, I'm going to use design guidance to generate a swing arm that connects the lower part of the frame to the axle at the center of the wheel. To begin, I'll click on the Design Guidance tab in the Action bar. To generate a design, I need to set up three items: restraints, applied forces, and a build volume. First, I'll add restraints, which I can create by clicking on Clamp, shown here, which keeps the selected faces fixed in place. I'll apply clamp restraints to all the faces on these two cylindrical mounts on the frame. And click OK. The second step is to apply forces to the model that it'll experience in real-world conditions. In this case, the ground is going to push up on the two tires because of the weight of the motorcycle and the rider. Each wheel carries half the weight, which gets transferred to the axle through the center of the wheel. To apply the forces at this location, I'll click on the force icon, then select the two faces on the underside of the axle. When applying a force, it can be set as a distributed force or a point force. In this case, I'll use a distributed force. Give it a custom value of 600 newtons. And I want to make sure the force is pointing upward. I'll choose the other direction option shown here. Then select an edge that exists on the frame pointing in the vertical direction. If needed, the direction of the magnitude can be switched by clicking this button. With all these options set, I'll click OK. Now I can perform the final step, setting the build volume and generating the design. To do this, I'll click on the New Design button shown here. And there's a number of settings that can be adjusted in the dialog box. In this case, I'm creating a new design, but if there was an existing part in the model I wanted to optimize, I could use the Redesign option. I'll show you an example of a redesign later on. There are 4 tabs shown here. In the Settings tab, I'm going to leave all the default options as is. In the next tab, Volume, I'm going to set the build volume by dragging the arrows in the graphic area. The location of the build volume can be relocated by dragging the center point. The overall size of the build volume can be scaled up by dragging the points at the end of these arrows. And each side of the box can be repositioned by dragging any of these arrows. I'll make sure they're all positioned where I'd like, which includes the full size of the axle and the mounts on the frame. I also want to mention that any of these parameters can be numerically input in these sections of the dialog box. So if you want a specific size or have it set at a particular location, you can specify those values here. It's important to take into account all other solid bodies that reside within this build volume. If there are bodies that I want to make sure don't interfere with the component that'll be generated, I can click on Exclude Regions and then select the bodies that should be excluded. In this case, I want to make sure the swing arm won't interfere with the wheel. I'll enable the Exclude Regions option, then select any of the faces on the wheel. The next tab, Symmetry, can be used to generate designs with specific symmetry incorporated. In this case, I'm not too worried about symmetry at this time, so I'll continue on. The last tab, Results, will populate once the geometry has generated. Now I'm ready to generate the geometry. I can simply click on the button Generate at the bottom, and the iterative process begins working on an optimal solution to the restraints, forces, and build volume applied to the model. This process can take a bit of time, but after a couple minutes, the solution is ready. Now the Results tab is shown, where I can adjust the slider to add and remove material depending on how stiff or flexible I may want the design to be. There's also a number of display options that can be applied to the generated geometry. I can show the granular results, switch to a wireframe view, and a couple other options. This produced a great starting point for generating the swing arm design, and in the next video, I'll add another layer of complexity by including the shock absorber mount shown here, as well as making adjustments to the build volume. Now that the first version of the generated swing arm is created, I want to add a bit more complexity to the design by attaching the swing arm to the shock absorber mount shown here. This means I'll need to include the forces placed on the shock absorber and expand the build volume of the swing arm. To begin, I'll add a new force to the shock absorber mount. I'll click on Force, and this time I'll be using a point force. I'll make sure to use a value of 600 newtons like I did before, and then select the top two faces on the shock absorber mount as the location. Now I want to make sure that the forces are pointing downward. To do this, I'll click on Other Direction, and then select the same vertical edge on the frame as the direction for the force. If needed, I can select the reverse button for the magnitude to switch directions. Now I can click OK, and the new force is included. Now I need to redefine the build volume of the generated body so that it includes the shock absorber mount. To do this, I'll edit the existing design guidance study item in the Design Manager, click on the Volume tab, and drag the top arrow upward so that it includes the shock absorber mount. I'll also make sure that the shock and mounts are selected as excluded regions, which will keep the new design from overlapping with these components in the design. Now I can click Generate, and the swing arm regenerates to account for the new force being applied. As I mentioned before, this can take a few minutes to generate, which I'll speed up to get to the final result. Notice how the design differs. The geometry extends higher up to connect to the shock absorber, and there's significantly more support geometry interconnected between the mounting points. Now this generated body can be used as an envelope or starting point for creating the actual swing arm that'll be manufactured. By referencing this generated body, the swing arm is ensured to withstand the applied forces experienced by the motorcycle. In the next video, I'll show you how to take an initial rough shape of the swing arm and perform a redesign on it to optimize its geometry. Here I have an initial rough block design of the swing arm. There's a bit more detail that's been created that connects this end to the motorcycle frame and this other end to the axle that goes through the rear wheel. The remainder of the geometry will be redesigned using design guidance, which will optimize the structural form and remove a significant amount of the geometry. To begin, I'll add clamp restraints to these cylindrical faces on this end of the swing arm body. I'll select both faces here, and both faces here, and click OK. Next, I'll apply distributed forces to the inner flat faces on each slot at this end of the swing arm. I'll click on both bottom flat faces within the slot cutouts. Make sure it's set as a distributed force. Set the total value to 1200 newtons, and click OK. Now I can begin the design guidance study. I'll click on the icon from the action bar. Select Redesign at the top since I'm redesigning the swing arm body. Then select any face on the swing arm to choose it as the body to redesign. I'll leave the build volume to include the entire swing arm. And since this swing arm design is a symmetric body, I'll use some symmetry settings to redesign the part. I'll click on Symmetry, use the At Center settings, enable the Z-axis option so that the body is split down the center, and click Generate. As you'd expect, this takes a few minutes to run, which I'll accelerate to get to the finished result. Now that the results are complete, only half the redesigned model is showing due to the symmetry condition. In the Results tab, I'll expand the Results Display section. Then enable the Show Full Design. And you can see the entire redesigned body with much of the geometry removed. I'll switch the model to a wireframe view to make it easier to see the redesign. From here, you can use the design guidance body as a design envelope or a guide to make adjustments to the swing arm body. Creating cutouts, applying fillets, and thickening specific sections will get closer to the final design according to the loads applied to it.